I think we are ready to start. It's 11:30 on my time. Is it good? Perfect, awesome. Thanks for joining me to my second presentation today. I'm going to talk about dependency management and where the fuck are we today. This is based on learning. So I'm working for Suse as an engineering manager. Feel free to follow and to reach out to me on Twitter if you want. Most of my work is open source, spending most of my time working on GitHub. So let's dig directly into the topic, the dependency management. Dependency what? So basically, dependencies are everywhere on our project, especially when you think about the full life cycle of your project. So you obviously have dependencies for your favorite languages, but you can also think about Kubernetes, for example, infrastructure, for example, when you think all the Helm chart that you may be using. When you think about the documentation that you build for your application, you also have a lot of links. So dependencies are really everywhere, and automating them brings you quite a lot of benefits. So obviously it reduces the technical debt when you can automate dependencies. It increases your confidence in changing your project. It increases security because you can easily get to the latest stable version that you're using. It allows you, that's probably one of the features that I like, it allows you to use new features. So when you have a tool that automatically bumps your dependencies, you sometimes have a small notification telling you that the project that you depend on introduced a new feature and maybe that you can leverage that feature. It allows you to regularly benefit from bug fixing and ultimately just save you a lot of time for later. But automating your dependencies can be really challenging, especially when you consider the data structure, the things that you want to automate, so not only libraries, but everything. You have a lot of challenges when you think about the version, the way teams version their application, and how you validate the upgrade. So let's just look at the data structure. So you can think of, okay, you have two kinds of data structure you want to automate. The first one is a pretty standard data structure. You know the file that you're looking for, and you know the content. So in this example, it's a simple, so for example, in this example is for JavaScript. So you know that if you have a JavaScript application, you should have a package.json in your Git repository. And the structure of that package.json is, pretty obvious. So you just look into and fetch all the dependencies. That's, I would say, the easiest That's the easiest scenario because you know what file to look for in advance, and so you can retrieve all the dependencies. But on the other side, you have a lot of more dependencies that you need to automate, and those dependencies can be hidden in many more files. So for example, I offer a beer to the person who can tell me what should be the next version for the image colon tag. And the simple reason is this file is just a random file fetched from a Git repository on the Jenkins project. And the thing is, it's really difficult to know, okay, what information should be there. And those kind of dependencies are pretty much everywhere. And when you want to automate this kind of dependencies, you don't really have a lot of choices. You could imagine an AI that can automatically detect the file, the kind of files, and for what use a specific file. Just to come back to the previous example, this image tag is just the RC bot that we use on the Jenkins project. So it's not really easy to identify what should be the next version for the Docker image used here. So if you think about all those scenarios where you have file, you have documentation, you have the configuration of your environment, whatever, and you want to automate them, you could think about maybe an AI that could automate that, but yeah, we are not there yet. We could enforce some standard way to update those data structure, but that brings us to have standard, which can be difficult. Or finally, we can take care of those updates by ourselves. The reality today is that's what we do. We just write bash scripts, or make files, or maybe a small Python script or small whatever script you want to use. And then you copy paste those scripts between Git repositories, so that can become really difficult to maintain on long term. So that's for the data structure. That's the first challenge to keep in mind. The second one that I have is when you want to automate those updates, you have to think about what are the versions that the project use. And in this case, I really think about all those third dependencies. So not only, for example, the project that the backend team is building in your company, but also, for example, okay, what's the versioning for Jenkins, for instance? And you have a lot of different kind of versioning. And when you want to validate that you can upgrade to a specific version safely without breaking your own application, you need to have information such as, okay, there is a new version, and can I safely merge this one? And what kind of information do I get? So let's look at the date versioning. The date versioning is, that's pretty much self-explanatory. For example, Ubuntu, we just put the date of the release. And so you know that when you have a PR opening on your Git repositories, you have a PR telling you that there is a new version available. And the only information that you know when you face that kind of situation is that you're trying to upgrade to a newer version. You don't have any other information. And in the end, you still have to look at the changelog, look at what would be, so you still need to test about what would affect, how it would affect your project. The other way to look at versioning is hash versioning. So for example, Docker image digest, git commit hash, you can building a checksum. This kind of versioning is interesting if you want to have you can identify a version with great precision, so you really know what you have in your, what you have in your infrastructure project, whatever, however you use that version. But the reality is, when you need to validate the change introduced by this kind of version change, it can be really cumbersome because, well, you have no idea if this hash match exactly the latest one. So in the end, each time you introduce a change, you need to manually run the validation, and that can be quite annoying, when in terms of validating. So for example, on the Jenkins project, we automated quite a lot of data using hash versioning because we really want to be able to identify what was running in the cluster. But after a few months, we decided that it was just too difficult to maintain those changes, and so we decided to stop using the hash versioning. Another pretty popular way to version your application is to use the build number. This one is, I saw a lot of projects using this one. I find it really annoying when I need to review a version change using the build number versioning because I don't necessarily have access to the CI environment that generated this version. And so the idea is, for example, in this case, it's still an example on the Jenkins project. We have the first three digits are the number of the job ID. So that was generated on the job ID 165. Then you have the build, and then you have a Git short hash. From an external contributor, when I depend on those kind of third dependencies, if I don't have access to the CI environment, it tells me nothing. And so in the end, I still have to look into the Git repository to know what's the real content of this release and how I can use this one. Then you come to the semantic versioning, which is the one that I just prefer. So the semantic versioning, the idea is we put some convention. And so a version contains three fields, x.y.z. The x mean it's a major version. So if you are introducing a breaking change, you know that you have to bump the major version. If you're just adding a new feature, you bump the Y, so the minor version. And if you're just bringing bug fixes, you just merge the Z. What is awesome with the semantic versioning is when you have a PR opening on your Git repository telling you that there is a new version using semantic versioning, then you know immediately if you can merge a PR and proceed, or if you have to plan maybe some work in the coming weeks to really take more time to test it to understand what's changing in this version. What is interesting when you have to review projects using semantic versioning is you really see those people who take care of not breaking that convention. You have some vendors who are not really paying attention. And more importantly, you have just projects who have version that looks like a semantic versioning, but are just not doing semantic versioning. So that can be quite confusing. And then I put in all other kind of categories of projects that have a specific versioning, but it tells you nothing about what changed between the version 232 and the 233. And you still need to look at the changelog. In the case of the Jenkins, I know the difference because I worked on it, but the first time I had to find the right documentation that explained me what was what the version mean in this case. And so you can put all the other projects in that category. So when I look at a new project and I have to work on something, I like to just stick to semantic versioning because then it tells me, okay, can I just validate the change and proceed? And I know that sometimes people are concerned to just introducing breaking change for every releases, and they don't want to have a version that looks like 99.0.0. But I think there is another question to ask is, I mean, does it make sense to just introduce breaking change at any releases? So the next big challenge that I faced while looking into the dependency management is when you want to validate and when you want to upgrade your dependencies, you have different ways to see the way to upgrade. So the first one is the pretty common one, I mean the one that all people think of, is an individual upgrade. So you have a dependency bumping, it open, for example, a PR, and then you validate that change, you merge the change, and then you test that change, and job done, it's awesome. The thing is, when you have, let's say, a JavaScript project with hundreds of dependencies, you can just spend your days validating PRs and merging PRs. And so it just introduced what we call it noise. So we have a lot of noise reviewing dependency change. And so some projects started using what we can see as batch upgrade. So the idea of a batch upgrade is you just group all the changes for a specific reason. For example, you want to bump let's imagine you have a Golang project and you want to bump the Golang project to the latest version, but not only in the Go mod, in the dependency file, but also in the CI environment, in the documentation, or maybe in other repositories as well, and maybe on your website. Then you could imagine a situation where you just bump everything at once, and then someone can validate that, and then we move on, and we don't fall in that trap where you have a different version of Golang in your CI environment that you have in your release environment, for example. So having batch upgrade can either reduce the noise, so you can just, let's say, imagine the situation where every Monday you review all the changes and you test all of them in once and then you proceed, or you can just change everything related to the same area. So that's how I started building a project named Update CLI. So the way it started, I was maintaining the Jenkins infra project. I had quite a lot of dependencies, and I had a lot of non-standard structure, and because the Jenkins project has the age that it has. And so we not only have Kubernetes, we have Puppet, we have a lot of applications developed in different languages. So I was facing quite a lot of non-standard data structure, and also I needed a way to just do batch upgrades depending on the situation. So what I can show you what it looks like now. So the project started as bash script, then evolved to Python, and then I switched to Golang. So I can just change I will just mirror my screen. So I can just show you what it looks like. You see my screen, that's awesome. So I have a small demo here, and I have two files. So the first one is the data file. So this is a random YAML file that I know that I want to update. And this file contains two information. It contains a container for the latest update CLI, for the update CLI hosted on GHR, and it contains a tag. And what I want to do here is I want to automate the update, retrieving the latest information. And before doing so, I need to show you one thing that I had to do in advance, otherwise my demo wouldn't work, is because I need to interact with the GitHub API, I need some credentials for this. And so I'm using Soaps. So for those people who are not familiar with it, Soaps is a tool coming from the Mozilla project. And it allows you to encrypt information and to publish them in a Git repository. So you have a bunch of information here. So it's really super project, I love it. And so here I have my file. So the file is named updatecli.ali.yaml. The name matter in this case because I'm leveraging JSON schema store to automate, to have syntax. So the way updatecli works is you need to write a manifest. Inside that manifest, you tell one pipeline means, for example, batch upgrade. You can update multiple things at the same time. One pipeline is one manifest, and you specify where the information is coming from, what you want to update, and how you want to do this. So I'm just, okay, right. Why it doesn't work? Okay, so as I was saying, JSON schema store is a convention. So if you publish the JSON schema for your project, you can automatically have suggestions when you write this one. So all you have to do from VS Code is just ctrl space, and so it suggests. So I'm going to do, I'll provide a title to my pipeline, demo silicon, for example. Then I specify the target. So the target is what I want to update. We can update one thing at a time or multiple things, and because we can have different things to update, I specify an ID. Space, so updates data.yaml. I specify the kinds. So the kind is, you can see it as a plugin. So we can, for example, when you want to automate the content of a YAML file, you don't provide the same information that if, for example, you want to automate the content of a Docker file or an M-chart, for example. So in this case, it's just a YAML file. I specify the spec. So the spec are the specific configuration for this one. The file is silicon 2022 / data.yaml. I specify the YAML key, which is, what was the file name again? It says, so it's image.container. .container. And so now I want to specify where the information is coming from. So I specify a source, let's say update CLI, and then I provide information for the source. Get latest update CLI version. Same, a source can have different kinds. So the information can come from different places. For example, it can come from a YAML file. In this case, it's a GitHub release. And so GitHub release has multiple fields that we need to provide. So the owner is the repository, which is update CLI. The repository is update CLI. We need to provide token. So it looks like a Go template. So I'm going to do github.username. I'm doing the same for the token. And then I need to review if I was using the correct one. So that information is, so the key that I'm using here is the one defined in the secrets.yaml, so .github username and token, which is great, seems to be working. And so from here, update CLI is a binary written in Golang. So we specify the manifest. So it supports, you can provide either a file or a directory. Secrets, silicon, this one. Let's see if it works. And so the way it works is you have, okay, changed, awesome, so it works. So the way it works is you have the core of update CLI that we always do the same. So first it tries to download all the Git repositories that your project rely on. Then it retrieves all the sources. In this case, we only have one, which is the latest update CLI version, so v0.25.0. It identified that we have a changelog available on the GitHub release. So I also have this information here. So I can know, okay, what we are introducing in the latest version. And then we have the targets. We can have one or multiple targets, so that allows us to have like a batch upgrade, for example. And in this case, what it says is we want to check that I'm using the wrong key. So in this case, instead of using image.container, I should be using image.tag. So you can see that I was trying to update from ghr.io/update CLI to the version. So it's obviously not the correct key. So it's a minor thing, okay? And then we have one additional resources that we could use, which is run some conditions, Docker. And what I want to do here is test Docker image. Docker image, spec. I want to specify gher.io/update CLI/update CLI. So before I execute the thing here is a source retrieve an information, and that information is injected in a condition or a target, so we don't have to re-enter the same value. So depending on the plugin that we use, the value is automatically filled. So in this case, it will automatically set the field tag. So this tag will be automatically set to the value retrieved from the source. So what I want to do here is a typical workflow that I use it everywhere in my project is I want to retrieve the latest version for a specific application. I want to test that there is a Docker image available for that specific version, and only then I bump the YAML file or, for example, the Helm charts. And so if I run this and I didn't do any mistakes, changed, awesome. So we now have one additional condition that appear here, which is, okay, we have the correct Docker image tag that exists on the repository, so we can go further. So this is really how the project evolved from building bash scripts. And so what is awesome, sorry, I will just show you, so far in question. No, I can just continue. So the way we use it, we usually have 1 to 3 manifests per Git repository that we try to automate, and we really focus on those non-standard data structure. And if for some reason the YAML file change, we can easily adapt the manifest to just say, okay, we are not anymore using container colon image, but we are using container colon, I don't know, nginx colon image. So we can easily change the workflow. And we could also think of more advanced scenarios. So I can show you one before. This one, for example, update CLI. So on my project, I usually have a directory named update CLI, which I don't see here. I don't see here. Why? Okay, here it is. Update CLI. Okay, right, so this one is an example. So in this case, we don't only want to change the file locally, but we want to automatically open a pull request, or we want to automatically commit directly to our Git repository. So we specify one SM resource. So in this case, it's a SM resource of type GitHub. So we specify the different parameters. We retrieve the value from the environment variable. So it's a different way to provide secrets. We retrieve the latest version. So in this case, it's the Hugo project. So we use Hugo to render the website of update CLI. And so we retrieve the latest version from Hugo. Then we realized that, okay, Hugo use a V into the version number, and that's why I was telling you that versioning can be really annoying, is because some project will put, for example, information such as Jenkins dash before the version, and in this case, Hugo used a V before the version, and I don't want it, so I just drop the V before the version, and then I will try to update my Netlify configuration. So each time I see a Hugo version, I will just bump to the latest version. I also bump directly the GitHub action. So I have a GitHub action that specifies the Hugo version, so I can test building my application automatically. And finally, I have a specific configuration for the pull request. And so what my pull request configuration looks like is it's a pull request of type GitHub. We specify the SM ID. We provide, we say, okay, which target is related to this change. We want to enable the auto merge flag on the Git repository. And we want to use the merge method squash, and we specify some labels. And so what it does is, if there is a new version for Hugo, it will automatically open a PR, trigger the test, so we will try to build a website, and if it builds, then we can just merge a PR and move on. So if I come back here, this way. So that's all I want to show with update CLI. It's an experiment that I started. I mean, the project. It's a project that I started, maybe 2 years ago on the Jenkins project, and we started using in many places. It's useful not only for dev dependencies. It's useful in many different scenarios because we automate Docker file update. We automate the release of Helm chart. So a typical example is for Helm chart is we have one in the case of Epinio where we retrieve the version from the backend team and the front-end team. And so as soon as one of the two versions is released, we can automatically automatically trigger a new Helm chart. And the backend team use GitHub release, while the front-end team just rely on Git tag for the releases. So it really depends. For the documentation as well, we automatically retrieve the latest version and we automate links in the different projects. And in the case of the dev environment, we use it to change the same version everywhere. So we bump the CI environment, we bump the dev, and we bump everything at once. That's it. So we've been using it a lot on different projects, and we learned quite a few things. So the first one is the command line tool is really great because then it gives you a feedback loop very quickly. So you just join a Git repository, run updates li diff, and then you automatically see what would change in the project. So if you want to just change locally, you can do the change locally, and then you can test all the things. It's really portable because it's a Golang binary, so it works on all the distribution, architecture, and so on. So, well, you can just run the command from the CI environment, so we use it from Jenkins and GitHub Action. On the other side, writing manifest is annoying, even though we pay attention to note. We never introduce breaking changes in the manifest, yet we still have to write those manifests. We have to store those manifests somewhere. At this time, I don't see any other way to automate dependencies where you don't know the data structure that you want to know, that you want to update in advance. So maintaining is a bit annoying because the way we proceed is we deprecate some keys, for example, in the manifest, and then we wait for a few versions before totally removing that key. So that means that from time to time, we need to do a bit of cleaning in the project. And well, we learn constantly. But on the other side, yeah, it brings us a lot of flexibility. So for example, if we realize that it's just too noisy to update a specific dependency, we just merge them into one specific batch. Into one pipeline. So it's an experiment. So it's a project that we started on the side, so I'm not working on it full time. We use it on the Jenkins project and a few other places, but yeah, it just is still at an experiment at this time. The different plugins are driven by what we need. So yeah, that's it. Yeah, if you have any question, let's talk. I would be curious to know how you manage dependencies updates. And yeah, if you want stickers, I have some stickers, and check out the project. Thanks. Any question? Yes?
Are you doing sort of like signing for the artifacts that you're releasing?
So the only thing that we do for signing in this case, we sign the Git commits. So we can sign commits. That was a PR coming. I mean, that was a PR that I received several months ago. I wanted to sign my commits automatically. So we can right now sign using GPG keys. So yeah, if you are interested, the thing is, we built it in a way that we can easily extend the different plugins. So for example, a source is just retrieving a version. So that's the easiest scenario. So you just have to write a function that tells you, okay, how you retrieve the version. So retrieving, for example, yeah, I show you GitHub releases. We have, for example, Maven repository. So that's really easy as soon as you have an API. When we want to run the condition that's the same, all you have to do is write a function that will just ensure that the thing works or not. When it comes to targets, it's a bit more difficult because then you need to update a file, for example, and that can be a bit more tricky depending on what you want to update. So we have some fallback. I'm maintaining infrastructure for quite a long time, so I rely a lot on YAML files. So we automate YAML files and Docker file. And the fallback that we have is just bump a file based on regex rules, which is sometimes convenient, but well, I like that story. I like that thing where you say you had one problem, you solve it with a regex, and now you have two problems to solve. And yeah, for me, it's really like, if I don't have any other choice, that's what I do. And otherwise, we can also run some small scripts. So an example of that is we use Docusaurus on one of the projects that I maintain. And I wrote a small script that just ran Docusaurus comments. So it can generate the website for the next version. Any other question? Nope. Sounds about right. Then I can turn off this.